03:17 a.m. Outskirts of Robotyne, Zaporizhzhia front. Inside a Russian Air Defense Command vehicle, the radar screen suddenly blooms with targets. 6, then 12, then more than 20. Headsets crackle as radio noise floods the spectrum. Signals overlap, identification collapses. "Engage!" the commander orders. 2 missiles tear into the night, white flames carving through the dark sky. Seconds later, silence. No confirmed kills. Only a chilling realization. They were never chasing real drones. Only reflections, decoys, ghosts in the electromagnetic fog. If modern warfare is a battle for perception, one question matters most. Who controls what you see? By 2025, the war in Ukraine had evolved far beyond artillery duels and armored thrusts. It had become a contest for electromagnetic dominance. Radios, radars, satellite links, GPS, every modern army depends on them. And on the southern front from Orikhiv to Tokmak, that invisible layer of the battlefield had turned into a lethal arena of its own. Russia entered the conflict with one of the most extensive electronic warfare arsenals in the world. Systems such as Krasuka, Zhitel, and Tirada were designed to jam communications, blind surveillance drones, and disrupt satellite navigation. In theory, these systems formed a protective umbrella shielding Russian maneuver units and air defenses from precision strikes. In practice, they also created a rigid dependency when the spectrum was quiet. Russian units functioned efficiently, but when it became chaotic, decision-making slowed and coordination fractured. Ukraine faced the opposite problem. It lacked numerical superiority in aircraft long-range missiles and layered air defense networks. What it did possess was adaptability. Forced to fight asymmetrically, Ukrainian planners leaned into speed, improvisation, and rapid experimentation. Drone units became laboratories. Electronic warfare teams worked alongside software engineers, signal analysts, and civilian tech volunteers. The goal was no longer just to evade Russian jamming, but to weaponize Russian expectations. The terrain around Robotyne amplified this shift. Flat farmlands, sparse tree lines, and long sight lines offered little concealment from radar. Traditional low-altitude flight paths were increasingly dangerous. Any single drone or aircraft operating alone was quickly detected, classified, and engaged. Survival now depended on saturation, deception, and timing. This was the strategic backdrop for Ukraine's new electronic warfare tactics. Rather than attempting to overpower Russian systems, Ukrainian units sought to confuse them, to flood sensors with contradictory data, to force air defense crews into split-second decisions based on incomplete information. Each false target increased the cognitive load on the operator. Each second of hesitation opened a window. The question was no longer whether Russian systems could detect incoming threats. The question was whether they could still decide what was real and fast enough to matter. The operation did not begin on the battlefield. It began weeks earlier inside garages, basements, and makeshift command posts scattered far from the front. Ukrainian electronic warfare teams treated Russian air defenses not as static threats, but as systems with habits patterns that could be learned, predicted, and exploited. Signal analysts started by mapping the electromagnetic environment. Using passive receivers, they listened rather than transmitted, recording how Russian radars behaved during routine patrols, how often frequencies shifted, and how quickly operators reacted to unexpected contacts. Every burst of radar energy, every spike of jamming power left a fingerprint. Over time, those fingerprints formed a profile. At the same time, drone units conducted deliberate probing runs. Single, low-cost UAVs were sent toward Russian positions not to survive, but to provoke responses. When a drone disappeared, teams measured what followed, which frequencies lit up, which radars activated, how long it took before missiles were launched. Each loss fed the model. What emerged was a critical insight. Russian crews were trained to prioritize speed over certainty. Faced with multiple fast-appearing targets, standard operating procedures favored immediate engagement to avoid saturation. That instinct, logical under pressure, would become the weakness. Ukrainian engineers then designed a layered deception package. Some drones carried minimal hardware, acting purely as radar reflectors. Others emitted short, irregular bursts of radio noise mimicking command links. A third group replayed previously recorded Russian radar responses back into the spectrum, creating echoes of echoes. None of these systems needed to be powerful. They only needed to be believable. Human factors mattered just as much as technology. Operators trained to fly while half-blind, reading degraded video feeds filled with static. EW specialists rehearsed timing windows down to seconds, knowing that transmitting too early or too late would collapse the illusion. Sleep was scarce. Mistakes were costly. By the time the drones were lined up on the edge of a frozen field near Robotyne, the goal was clear. This was not about destroying Russian air defenses outright. It was about forcing them to react, to reveal themselves, to burn through missiles, to expose command nodes. The real strike would come later. First, the fog had to be thick enough. The first drones lifted off just before dawn, their electric motors barely audible above the wind sweeping across the fields. From the Russian side, nothing seemed unusual at first. A single contact appeared at long range, slow, low, insignificant. Then another. Then several more, spaced just far enough apart to suggest coordination, but not enough to confirm it. Inside the Russian air defense network, operators began tagging targets, friend or foe. Too small for aircraft, too numerous to ignore. As procedures demanded, tracking radars powered up, sweeping the sky with narrow beams. That was the moment Ukrainian teams were waiting for. A second wave followed. These drones flew lower, skimming barely meters above the terrain, their radar cross-sections deliberately exaggerated with simple reflectors. On screens, they looked larger than they were fast-moving, erratic, potentially armed. At the same time, Ukrainian EW units activated short bursts of interference, not strong enough to blind the radar, but enough to distort range and speed readings. Targets seemed to jump, split, recombine. Russian crews reacted instinctively. Engagement zones were defined. Missile batteries shifted to combat mode. Command posts began transmitting more frequently, coordinating between sensors, launchers, and higher headquarters. With every transmission, their electronic footprint grew brighter. Then came the saturation. Multiple decoy drones suddenly appeared from different bearings, their signals overlapping in time and frequency. To an operator staring at a cluttered screen, the picture was overwhelming. Some tracks faded, others multiplied. The system struggled to prioritize. A decision had to be made now. Missiles launched. Each launch solved one problem but created another. Radar emissions spiked. Launch signatures revealed precise locations. Ukrainian observers watching through passive sensors and distant optical feeds marked coordinates in real time. The illusion was working. As Russian air defense units focused on the swarm, a separate Ukrainian drone slipped through a gap at extremely low altitude, its video feed degraded but usable. The operator adjusted by instinct rather than clarity, flying by contrast and motion rather than detail. Every second counted. Above him, missiles chased ghosts. Russian countermeasures followed quickly. Jamming power increased, flooding entire bands. Some Ukrainian drones lost control and crashed harmlessly into fields. Others went silent, executing pre-programmed routes. The battlefield became chaotic machines reacting to machines, humans trying to keep up. At one point, a Russian interceptor drone was launched, climbing aggressively to meet what appeared to be a high-value target. The contact vanished mid-climb. The interceptor overshot, stalled, and fell away. It had chased a reflection. By the time the final decoys burned out or were destroyed, the engagement zone looked quiet again, but it was a deceptive calm. Russian air defenses had fired expensive interceptors, exposed command nodes, and saturated their own spectrum with noise. Ukrainian units had lost drones but gained something far more valuable: clarity. They now knew exactly where the eyes and fists of the defense were, and that knowledge would shape what happened next. As the swarm faded, Russian commanders attempted to reassert control. Orders were issued to reset systems, reclassify the air picture, and restore a coherent hierarchy of targets. But the electromagnetic environment no longer behaved predictably. Jamming from multiple directions, some real, some residual, continued to interfere with data links. Screens cleared, then cluttered again. Confidence did not return with the silence. Air defense units shifted posture, launchers repositioned, radar operators shortened emission cycles, turning systems on only briefly to avoid detection. Yet this caution carried its own cost. Each pause created blind spots. Each brief activation still revealed a location. The defense was no longer continuous, it was fragmented. Command and control channels struggled most. With units dispersed and communication degraded, local commanders began making autonomous decisions. Some held fire to conserve missiles. Others launched preemptively at the first hint of contact. The result was inconsistency, overlapping coverage in some sectors, dangerous gaps in others. Russian electronic warfare teams attempted counter-jamming, flooding wider frequency bands with brute force power. The effect was immediate but blunt. Ukrainian signals weakened, but so did Russian internal communications. Navigation errors appeared, timing desynchronized. The spectrum became a noisy mirror reflecting confusion back at its source. What made the situation especially dangerous was uncertainty. Russian crews could not tell whether the previous swarm had been a feint or the opening move of a larger strike. Every new blip carried the possibility of a follow-on attack. Fatigue set in quickly. Operators stayed glued to their screens, afraid to miss the next cue, unsure which cues mattered. In trying to defend against everything, they defended against nothing particularly well. The system still worked. The missiles still flew. But the cohesion, the sense of control that modern air defense depends on, had been eroded. And in warfare, erosion is often more decisive than destruction. At the core of Ukraine's success was not raw electronic power, but cognitive overload, engineered through the electromagnetic spectrum. Russian air defense systems are designed to defeat real physical threats. Aircraft missiles, drones by tracking speed, altitude, trajectory, and signal consistency. What they are far less optimized for is ambiguity at scale. The first mechanism at play was saturation without mass. Instead of overwhelming defenses with dozens of lethal drones, Ukraine used a mix of decoys, reflectors, and low-power emitters to simulate density. From the radar's perspective, the sky appeared crowded. From the command system's perspective, it became a prioritization nightmare. Every additional target increased processing demands and shortened reaction windows, forcing operators to act before certainty was possible. The second mechanism was signal plausibility. Ukrainian EW teams did not attempt to fully blind Russian radars. Full-spectrum jamming is easy to identify and counter. Instead, they introduced subtle distortions, range jitter, inconsistent velocity returns, brief packet loss, and command links. These effects resemble real-world clutter terrain reflections. Weather interference or low-quality sensors, the result was doubt, not blindness, and doubt slows decisions. Third was feedback exploitation. Russian doctrine emphasizes rapid engagement to avoid being saturated. Ukrainian planners counted on this. Every radar activation, every missile launch, and every command transmission revealed location, timing, and system type. Passive sensors could harvest this data without emitting anything themselves. In effect, Russian defenses were teaching Ukraine how they worked live under combat conditions. Cost asymmetry amplified all of this. A decoy drone costing a few $100s forced the expenditure of missiles worth hundreds of thousands. More importantly, it forced crews to expose high-value systems that would otherwise remain hidden. Even when intercepts were successful, the exchange favored the attacker. Finally, there was the human factor. No automated system fully replaces judgment. Operators under stress default to training. When training assumes most targets are real, deception becomes disproportionately powerful. Ukraine did not defeat Russian technology. It reframed the problem Russian crews were trying to solve. In modern warfare, the side that controls the narrative of the battlefield, what appears urgent, what appears real, often controls the outcome. This engagement was a textbook example of that principle in action. The immediate effects of the engagement were subtle but decisive. No dramatic explosions dominated the headlines. No single system was publicly confirmed destroyed that morning. Yet within hours, Russian forces along the sector began adjusting their posture. Radar sites relocated. Air defense coverage thinned as units spread out. Missile expenditure reports showed an unusually high burn rate for a contact phase that had produced no confirmed kills. For Ukraine, the payoff was intelligence and momentum. The data collected during the engagement, emission patterns, reaction times, command link behavior fed directly into follow-on planning. Strike packages could now be routed around known sensor gaps. Long-range fires gained more precise target sets. What began as a test became a force multiplier. At the operational level, the event reinforced a shift already underway. Russian units increasingly treated the electromagnetic spectrum as contested territory rather than a secure advantage. That caution slowed response times and reduced confidence in automated systems. Defensive doctrine became more conservative, trading coverage for survivability. Beyond Ukraine, the implications reached far wider. Military planners across NATO, Asia, and the Middle East took note. The lesson was not that air defenses were obsolete, but that they could be manipulated without being destroyed. Small states and non-state actors could, in theory, replicate elements of this approach using commercially available technology and modest expertise. The engagement underscored a new reality. Dominance in modern warfare is no longer defined solely by who owns the most advanced hardware. It is defined by who best understands how that hardware is perceived, trusted, and ultimately used under stress. And that realization unsettles every army watching closely. The engagement near Robotyne did not rewrite the laws of war. It revealed how those laws are quietly being bent. No fortress was stormed, no frontline collapsed overnight. Instead, a handful of engineers, operators, and analysts showed how perception itself could become a weapon. Ukraine's new electronic warfare tactics demonstrated that victory does not always come from destroying an enemy's tools, but from forcing them to misinterpret reality. Russian air defenses fired when they should have waited, exposed themselves when they should have remained hidden, and hesitated when clarity mattered most. None of these failures were catastrophic alone. Together, they reshaped the battlefield. This is the direction modern conflict is moving. Cheaper systems, smarter coordination, and an emphasis on human decision-making under stress are narrowing the gap between large, well-funded militaries and agile adaptive forces. The electromagnetic spectrum, once a support domain, is now a front line in its own right. For those watching from afar, the lesson is uncomfortable. Future wars may be decided long before the first missile hits its target. They may be decided in the moments when operators stare at flickering screens, unsure whether what they see is real and forced to choose anyway. Understanding these moments matters, because the next conflict may not begin with an explosion, but with silence, static, and a question no system can answer for you. Bye for now.